Hi everyone, this is Babaiah, Assistant Professor of AC Department from MLR Hyderabad. Today I am going to explain about the time response or transient response of the first order system for the given input as unit step input, right? We have a standard test signals. We have to test the any system by applying the standard test signals. The standard test signals are like step signal or unit step signal, ramp signal or unit ramp signal, parabolic signal or unit parabolic signal, impulse. All these are the test signals or standard test signals which are used to test the given any system performance. So here I am going to calculate the or derive the time response or transient response of the first order system by applying the input as a unit step input, right? Coming to the overview of today's session, just here calculation of time response or else derivation of the first order system. When I am going to apply the input as a unit step, that is the today's section, as well as what is the response graph or else output graph. We are going to see all these 2 points here. Coming to the calculation of time response, for that I am going to consider the first order system. Here in figure I am going to write here the figure name is the, or I am going to consider the first order first order closed loop system with unity feedback system. Consider first order unity feedback system unity feedback closed loop control system. Here unity feedback closed loop control system. Here the first order system, this one is the first order closed loop unity feedback system. Just here observe in this, the my input is R of S and output is the C of S, and here the first order system is here 1 by Ts. This is the open loop gain or open loop transfer function 1 by Ts. Here the order is nothing but what in previous session we learned the what is the meaning of order as well as the type number of the system. Right here order is nothing but what the maximum power of the any differential equation or else the maximum power of the S domain or else S domain equation, the maximum power of S we call it as the order of the system. Here see observe in denominator here 1 by Ts, the first order system here is power of 1 only, so it is considered as the first order system. S term is only 1. So here the feedback is unity, that is nothing but H of S equals to 1. Unity feedback is nothing but H of S equals to 1. So here just I am going to solve this one. The transfer function of the given unity feedback system is T of S equals to C of S divided by R of S equals to, general formula is what is the transfer function of any closed loop control system. Simply we say that G of S divided by 1 plus G of S into H of S, where H of S is the unity feedback. H of S is the unity feedback means here consider as G of S is here, G of S equals to 1 by Ts. 1 by Ts is nothing but here G of S, and H of S is equals to 1 because of unity feedback. So now I am going to substitute these two in this equation. 1 by Ts divided by 1 plus G of S is nothing but 1 by Ts or St into 1. So by this solve simply 1 by Ts divided by Ts or St plus 1 divided by Ts. Here in denominator Ts is there, here Ts is there, both these two are going to be cancelled. Next finally we are going to get the transfer function of the First order closed loop control system with unity feedback system is directly 1 by 1 plus st or ts. This is the transfer function. That is nothing but C of s divided by R of s. C of s divided by R of s is nothing but 1 by 1 plus st or ts. This is the transfer function. This is the transfer function of the first order unity feedback system. Here, just observe. Now, what is the input for this condition is the input is unit step. For input is unit step. Unit step for input is unit step. Sorry. The for input is unit step input. So consider as unit step input is here R of t equals to 1. R of t equals to 1 simply here. See, R of t equals to 1 means here after applying the Laplace transform for this equation R of t equals to 1 and then apply the Laplace. Laplace means here Laplace transform of R of t is nothing but what? It means consider as the R of s in time domain into the is domain function, that is nothing but R of t equals to R of s, that is equals to here 1 is Laplace of 1 is nothing but here Laplace of 1 is just I am going to write here directly Laplace of 1 is nothing but 1 by s here. So R of s that is equals to R of s equals to 1 by s simply. Okay, now we know R of s equals to 1 by s. Here C of s by R of s here. The transfer function C of s by R of s equals to what? 1 by 1 plus st, right? 1 by 1 plus st. Here we know the R of s for R of s equals to 1 by s for unit step input. Unit step input R of s equals to 1 by s. Just to substitute in place of R of s. In place of R of s I am going to write here C of s is equals to R of s into 1 by 1 plus st. So 1 by 1 plus st. C of s equals to R of s into 1 by 1 plus st. Here just to substitute. In place of R of s, C of s is equals to, in place of R of s, 1 by s, 1 by 1 plus st. This is our equation, output equation. For this output equation, we are going to calculate the time response. This is in the form of S domain. In S domain, we are going to convert the equation into the time domain. Here, two equations by partial fraction. By using the partial fraction, C of s equals to, next here C of s equals to what? C of s equals to 1 by s into 1 by 1 plus st. 1 by 1 plus st. So here, now I am going to use the by partial fraction. By partial fraction, it is can be divided into here C of s equals to 1 by s and or else completely I am going to directly write here I am going to here t is just common. See here 1 plus st here 1 by s. Already we know this equation here. See next 1 by s into 1 by 1 plus st, right? This equation up to here clear. Next here I am going to common the t common from this equation, output equation. Here see t is common. So here t is common means here 1 by s and here 1 by st or 1 by t plus s plus t form. Here. So now I am going to direct writing into here this equation. C of s equals to 1 by t divided by s into 1 plus 1 by t plus s, or s plus 1 by t, s plus 1 by t. Now I am going to apply the partial fraction for this equation. Directly here I am going to apply now. Now apply the partial fraction for this equation. Equation number 1, for example. Equation number 1, by partial fraction C of s equals to 1 by t divided by s into 1 by t plus s, that is equals to a divided by s, this term, a divided by s. Here 1 by t is just a constant value. Here a by s, two s terms are available, a by s plus and b divided by s plus 1 by t, b divided by s plus 1 by t. This is the equation. Now I am going to just here equation number 2, just I am going to consider as equation number 2. A is obtained. Now I am going to calculate the a value and b value. After that, substitute the two values in this equation. Then we will get the output or response. Okay. So here I am going to calculate the a value for obtain the, or else for obtain the a value, or else a is obtained, any terms you can use. A is obtained, A is obtained by multiplying the here just simply a value is, for a value we are going to multiplying the s plus 1 by t for the c of s, by multiplying c of s with c of s a value. So here a value is denominator is only s, right? So c of s with s, and letting s tends to 0 or s equals to 0. Here s term only, here a by s only. So c of s multiply with the s and s equals to 0, substitute, then you will get the a value. Here for example, a is equals to, a is obtained by c of s with multiplying the s, multiplying by s and letting s tends to 0, right? Here we know the c of s. So c of s is nothing but what here, 1 by t divided by s into 1 by t plus s, or s plus 1 by t. Next here substitute s equals to into s, letting s equals to 0, right? Here s both are get cancelled, s equals to 0, substitute here 1 by t divided by 1 by t. So a equals to 1 by t divided by 1 by t, that is nothing but a equals to 1. So a equals to 1, a equals to 1. This is the a value. And next calculate the b value. This is the a value calculation. What we are doing here for the calculation of a, just simply multiply the c of s with a value divided by s, right? A divided by s, in denominator is s only there. So just multiply with the s, you will get this a equals to 1. Next again same procedure apply for the calculation for the b value. B is obtained by multiplying the c of s with in b denominator term is what, b divided by s plus 1 by t. So multiply with the s plus 1 by t and let s equals to minus 1 by t. Simply just here denominator part is s equal, s is there. So directly s equals to 0. S plus 1 by t. Next term s plus 1 by t equating to 0 means you will get s equals to minus 1 by t. Just substitute in place of s minus 1 by t. For calculation of b value, just here b is obtained B is obtained by multiplying the C of S with S plus 1 by T and letting S equals to minus 1 by T. Here minus 1 by T. S equals to minus 1 by T. Simply here B value. Now substitute or calculate the B value. For that, B equals to here C of S is nothing but 1 by T. Here just see this one. C of S equals to what? 1 by T divided by S into 1 plus S plus 1 by T. Here 1 by T divided by B value is obtained for, now I am going to write here 1 by T divided by S into S plus 1 by T multiplied with the S plus 1 by T and let S equals to minus 1 by T. In place of S substitute minus 1 by T. Here S plus 1 by T, S plus 1 by T. These two are get cancelled. So B value equals to 1 by T. Here S equals to minus 1 by T. So 1 by T divided by, here in place of S substitute minus 1 by T. So 1 by T both cancel. So you will get the minus 1. So B equals to what? B equals to, therefore B equals to minus 1. These two values. We know A equals to 1 and B equals to minus 1. Just to substitute the output equation, C of S is equals to, just simply C of S is equals to, substitute here A divided by, or else substitute the A value and A and B value. Just to substitute A and B values, substitute A and B values, substitute in equation. See here, equation is 2. In second equation, this second equation 2, that is C of S is equals to A divided by, second equation is what? A divided by S plus and B divided by S plus 1 by T, right? S plus 1 by T. So here just simply A equals to 1 and B equals to minus 1. So C of S equals to A by 1 by S plus minus 1 divided by S plus 1 by T. Now I am going to convert this S domain into the time domain. So because of we are going to calculate the time response or transient response for the system. So just directly, now I am going to apply the Laplace transform. Here Laplace transform for C of S equals to this one, and I am going to apply here just simply apply the Laplace transform to the, going to consider the equation 3 to the equation 3. So here Laplace of C of S is equals to, so this one is S domain to time. So inverse, we are going to use the inverse Laplace transform. So inverse. So inverse Laplace, or here just apply the inverse Laplace transform to the S domain equation. That S domain equation consider into the time domain. Just to simply inverse Laplace of C of S is equals to, and inverse Laplace of 1 by S also here, minus here just common, inverse Laplace of 1 divided by S plus 1 by T, S plus 1 by T. Here same, you know this formula for just to inverse Laplace of, or Laplace of e power of minus CAT, nothing but what, 1 by S plus A, 1 by S plus A. Here this is the Laplace. For inverse Laplace, just opposite. This is the inverse Laplace of 1 by S plus A. Here A is nothing but 1 by T, and here S is there, S plus 1 by, or S plus 1 by T. Here A equals to T, just substitute A equals to 1 by T. A equals to 1 by T. Here 1 by S is directly here, C of S is nothing but C of T. Inverse Laplace of 1 by S equals to 1, and here inverse Laplace of 1 by S plus A. You know this formula, same. Laplace of, the Laplace of 1 is nothing but what, 1 by S, 1 by S. So these two formulas just apply here. Inverse of, this is inverse, Laplace of 1 is 1 by S, inverse Laplace of 1 by S is nothing but here 1. So here 1 minus inverse Laplace of 1 by S plus 1 by T is nothing but the e power of minus A plus, in place of A just to substitute the 1 by T. 1 by T here, e power of minus 1 by T, 1 by T, and here T is there, again T is there, so T. So that is the output equation is directly, just I am going to write here, the time response or transient response, time response or transient response, of first order system is R of T is C of T is equals to, C of T equals to 1 minus e power of minus T by capital T, or here capital T or else tau, anyone you can use, capital T or tau, that is nothing but the T is a time constant. Here C of T equals to 1 minus e power of minus T by T for the unit step, input. For unit step input. For step input, C of T equals to A into 1 minus e power of minus T by T. This is for step input. Step input. For step input, just to multiply the A with the unit step input. Unit step input for step into conversion step input, just to multiply the A. Here A equals to 1, nothing but the unit step. A equals to 1 is nothing but the unit step. Right? This is the response or transient response or time response of the first order system for unit step input C of T. Now I am going to calculate the T values or response values for the design of a graph. Just I am going to consider here when T equals to, for example, when T equals to 0, substitute in the equation, I am going to consider this equation as a fourth equation. 0, substitute when t equals to 0, the output equals to what? C of t equals to what? Here 1 minus e power of minus t by t. T means here 0 value. So 0 by something value is 0. Directly here 1 minus e power of 0 is equals to what? 1 minus e power of 0. E power of 0 is nothing but what? E power of 0 equals to 1. So 1 minus 1 equals to 0. The value is C of t equals to 1 minus e power of. Here C of 0 equals to, you will get the 0, right? C of 0 equals to here 0. When t equals to 1t, time constant here, when t equals to 1t, substitute I am t in place of t. Here output C of t equals to what? 1 minus e power of minus t divided by t. T both cancel. 1 minus e power of minus 1. 1 minus e power of minus 1 equals to what? Here just take the calci and just here 1 minus in calci just write substitute 1 minus, take the exponential term, so shift and exponential e power of x function. E power of x function just shift and exponential. Just select on the calci. You will get this 1 minus e power of minus 1. E power of minus 1, that is C of t equals to 1 minus of e power of minus 1 equals to minus 1 equals to 0.632 when t equals to 1t. Same as when t equals to 2t, just substitute C of t equals to 1 minus e power of minus 2 in place of tt. Here just take the calci, again in place of minus 1 just write the minus 2. You will get the value 0.864. Again same, you should consider the 3t, that is C of t equals to 1 minus e power of minus 3. Just take the calci, again e power of minus 3. 1 minus e power of minus 3 equals to 0.9502 or else 0.9. Next third value, this is next, again consider the t equals to 4t. When t equals to 4t, C of t equals to 1 minus e power of minus 4, that is equals to minus 4 1 minus e power of minus 4. The value is 0.98. Same as t equals to 5t. C of t equals to 1 minus e power of minus 5. In place of minus 4, just substitute the minus 5. You will get the value 0.99. For this 0.9 approximately it is equals to the 9 equals to the 1, right? So from the 5t onwards you will get the steady state output or steady output. Here see, here in a time, just I am going to draw the graph. See here, observe. For the t value for 0 is nothing but here 0, the output C of t. Response for the input C of t equals to, for 0 is 0 value. For 1t you will get the value here. See, observe. For 1t 0.632 here 0. Some 0.632. Next here 2t 0.865 and 3t, here this is the 1t and here 2t and here 3t and 4t and 5t here and so on. 1 second. Here t, 4t and 5t and so on. Here for 3t value is what? How much you got the 3t? Just to substitute here. 3t already we calculated. This one 3t is 0.95. 0.95 and 4t is nothing but 0.9. 0.9 here 0.98 and last 0.99, that is approximately 1. So here 1. This is my output. So this is the 1. So from 5t onwards, from 5t, for the t equals to 5t, the response of the unit step input, this is the response of first order system for unit step input. This is my output. From t equals to 5t or from 5t onwards, or for 5t onwards, from 5t onwards, the time constant or else the response, the system is obtain the steady state response here. From 5t onwards, the system response is steady state output or steady state, where t is nothing but here, where t equals to time constant. Already I said time constant. T is nothing but here time constant. T is time constant. Time constant is nothing but the time for 0t and 1t, 3t, 2t, 1t, 2t, 3t, 4t, 5t and so on. You will get the graph like this. This is the response of the first order system for unit step input. Just I am going to write here first order. The figure name is just response of first order system for unit step input. This is the output. Okay, this is the graph of the time response for first order system, and output equation is C of t equals to 1 minus e power of minus 1 by t e power of minus t by t. This is the very important equation. This is the transient or time response, and this is the procedure to calculation or calculation of the transient response or time response of the first order system for unit step input. See here, this is just to consider the first we or consider the one closed loop feedback control system. Means here feedback is unity feedback control system, that is the first order system. For that, and calculate the transfer function. After that we are going to apply the apply the bipartial fraction method. Just we are going to calculate the a and b values. So after that, the s domain into the time domain conversion, we are going to apply the inverse Laplace for the equation. Finally we are going to we got the a and b values, then the a and b values substitute in the equation, output equation. That output equation just consider as a 1 c of t equals to 1 minus e power of minus t by t. This is the equation, transient or time response of first order system for unit step input. We got this equation. For the graph, for the design of the graph for the unit step input, consider as t equals to 0 and 1t, 2t, 3t, 4t and so on. Like that, from 5t onwards we are going to get the steady state output. Here the steady state output for the from 5t onwards. So t equals to 5t onwards you will get the, or else we are observe the from output is a steady state output. This is about the transient or time response of the first order system for unit step input. Time constant is nothing but the time reaches to, here the time constant is nothing but the time reaches the value, the time response of the, or else the time taking, it's take the time, the response to reach up to the 63.2 percentage or else 0.632. That is nothing but the time constant. Here time constant is t value for 1t is the value is what, 0.632 percentage, right? The response, it is take the time to reach the response up to 0.632 or 63.2%. That is known as the time constant simply. Okay, this is about the transient or time response of the first order system for unit step input. Thank you all.